All right, so using the packet of notes you were already given, relationships of all the angle pairs we looked at, alternate interior, exterior, same side interior, exterior, and corresponding angles when a transversal cuts through two parallel lines. So when we discussed it at first, it was just two lines cut by a transversal. So first I'm going to introduce the notation for parallel lines. So this will be the transversal, and when you see parallel lines, you'll see these markings on there. They're arrows headed in the same direction. Okay, so let's go through each figure, identify the transversal, and then we'll put on the parallel lines marking. They don't necessarily need to be on top of each other. They just need to be on both lines. Transversal. You could also see it doesn't necessarily need to be filled in. Just arrows headed in the same direction. Transversal. Parallel lines. Here's our transversal. More parallel lines. Okay. So looking at the angles marked, all right, opposite sides of the transversal, so they're definitely alternate, and then they're outside the parallel lines, so this relationship, alternate exterior angles. When two parallel lines are cut by a transversal, alternate exterior angles are congruent. Okay, so what does that mean? It means that the measure of the angles are equal. Okay, so when I look at this, I'm on the same side of the transversal between the parallel lines. So these are our same side interior angle relationship, and same side interior are supplementary. Oops, sorry about that. And what do we know about supplementary angles? They sum to 180 degrees. All right, when I look at the next one, same side of the transversal outside the parallel lines. So these are same side exterior angles. Same side exterior angles are supplementary as well. Rid of that. So when I look at this relationship, same side of the transversal, one angle is in the exterior, one angle is in the interior. So their relationship is that the angles are corresponding, and corresponding angles are always congruent. So we know the measure of their angles are equal. Lastly, I look here, opposite sides of the transversal, both inside the parallel lines. So these are alternate interior angles. Alternate interior angles are congruent, and therefore their measures are equal. All right, so this is a big one. These relationships only exist when the lines cut by the transversal are parallel. The lines have to be parallel in order for any of these relationships to be true. Oh, that didn't work. Okay. All right, so take a minute, pause the slide, copy the figure. We're going to use this figure to find all the missing angle measures. Okay, so a couple things to point out. I see that the lines are parallel, so then all my relationships can work. Alternate interior angles, alternate exterior angles, corresponding angles are all congruent. Same side interior, same side exterior, they're supplementary, so we know they add to 180. And then we also have our vertical angles and our linear pairs. All right, so starting at 132 degrees. If this is 132 degrees, then 3 is vertical to 132 degrees. So that's going to be congruent. When I look at 132, if I find its corresponding angle measure. So same side of the transversal, this is the exterior, which makes 5 the interior angle. And now if I look at 5 and 7 are vertical angles. So the measure of angle 3 is 132 degrees. The measure of angle 5 is 132 degrees. And the measure of angle 7 is 132 degrees. All right, so now if I go back to my given information, now if I look at 132 degrees and 1, now they form a linear pair. So I know the measure of angle 1 plus 132 degrees has to equal 180 degrees. Subtracting 132 from each side, I get the measure of angle 1 to be 48 degrees. So if I put 48 degrees in here, now I see 1 and 2 are vertical angles. Now when I look at 2 and 4 are alternate interior angles, and then 4 and 6 are vertical angles. And these aren't the only justifications for this. Okay, so the measure of angle 2 is 48 degrees, the measure of angle 4, and the measure of angle 6. So what's nice about these problems is when you have two parallel lines cut by a transversal, you're only ever going to get 2 angle measures. These 2 measures are all 8 of those. 4 for 132 degrees and 4 with the supplement of 48 degrees. All right, copy the figure, solve for x. When I look at this, I don't have parallel lines cut by a transversal, but I have a relationship that we've already studied. These angles are vertical angles. Vertical angles are congruent, and therefore their measures are equal. So I'm going to set the expressions equal to each other. I'm going to subtract 2x from both sides. I get 3x minus 11 equals 64. I'm going to add 11 to both sides. So 3x equals 75. Dividing by 3, I get x to equal 25. So just because we're studying the angle pair relationships, parallel lines cut by a transversal, doesn't mean that we can forget about the other ones we've learned. Okay, next, use the figure to solve for x. Okay, so now I have my parallel lines. Here's my transversal. Now let's determine what their relationship is. So this angle and this angle, they're both exterior. They're on opposite sides of the transversal. So we have alternate exterior angles. Alternate exterior angles are congruent, and therefore their measures are equal. I set those expressions for x equal to each other. Subtract 3x from both sides. So I get 10x plus 19 equals 17. Subtract 19, I don't like this already. 10x would equal negative 2. Dividing both sides by 10, I would get negative 0.2. I don't like having a negative value. Bad example, but the steps would remain the same. X can't be negative because it would make our angle measures negative as well. All right, and last example, use the figure to solve for x. Parallel lines cut by a transversal, so let's figure out this relationship. So they're on the same side of the transversal. One angle is on the exterior, one angle is on the interior. So these are corresponding angles. When parallel lines are cut by the transversal, corresponding angles are congruent. So I can set those expressions equal to each other. All right, first I'm going to subtract 18x from both sides. and I get 29 is equal to 6x plus 5. I'm going to subtract 5 from both sides. 24 is equal to 6x. Then my last step, divide by 6. I get a value of 4 for x. That's it.